Paleontologists doing research on dinosaur bones at the Springfield Science Museum noticed something interesting on a massive specimen that's been in the collection there for more than 80 years. That led to more research and possibly the identification of a new species of Tyrannosaur, 68 million years after the creature roamed the Earth. David Stier, director of the Springfield Science Museum, came in to tell us more.
The original bone that we were looking at was actually a humerus bone, which is an upper arm bone on us, but it's a leg bone on a four-legged animal. So we had it on display as early as 1982 in the dinosaur hall that we have. And again, it used to be a touch specimen. He started researching it, and he found out that that actually is the largest humerus from this formation in New Mexico. And, you know, it's from an animal called Allosaurus samwinensis. And that actually is the largest sauropod, plant-eating dinosaur that's been found in North America. So that sort of started the odyssey of the new bone. So, you know, in order to do an exhibition, we tried to have as many complementary elements in it. And one of the things that we typically would show would be a bone that was taken from the field in a plaster cast. So it just sort of shows how researchers try to get things as safely as possible from the field back to study it, you know, at their own laboratory. So we were working on this bone, and so two things were happening. First of all, he looked at this jacketed bone, and he had been looking at a bone elsewhere at the Benesky Museum. And he felt like it was unique enough that it warranted more study. So they were ready to name a new species based on just a partial jawbone. And it turns out that we actually had other material that had been collected way back in 1924 by Professor Loomis at Amherst College. We don't know why. Amherst College doesn't know. We don't know why we ended up with this material. But we actually have more material of this animal. And we thought it was T-Rex. It had a notation on it called Hell Creek, Montana, and that's, you know, typically a place where they found T-Rex. So for many years I put this out on display. Well, he ends up determining that it actually matches material at the Ojo Alamo Formation, same place where this other, you know, sauropod was found. And, you know, it constitutes what he believes is a new species.
What does it mean in the academic and scientific community for the Springfield Museum to have part of your collection involved in this kind of potentially, you know, earth-breaking research and potential discovery? I mean, it's a big deal.
Oh, this is, you know, I mean, that's why we're here. We, you know, when we're trained to become, originally I was a curator, and I still am after I became director. But, you know, we're supposed to take care of things for perpetuity, and that's kind of a long time. And now you know why. You know, you mentioned earlier, this was collected in 1924. 10 years later, it came into the museum. It's been cared for that whole time. But, you know, obviously the information associated with it wasn't entirely factual. All they knew was that it was a plant-eating dinosaur. They knew it was a sauropod. So, you know, now we get a chance to actually, we name, you know, this bone, we know more about it. But this new species, that's yet another thing. I mean, in order to name a new species, it really needs to be, it's very extreme cases where a single bone or an element of something would be sufficient enough to name a species. So they have things called type specimens, and then there's syntype and paratype and lectotype. Those are all science terms, but basically they have the characteristics that demonstrate, you know, pretty confidently that this is a new species. And so, you know, there will be other study on this material. We have other things in the collections. I'm really excited because, you know, you take care of it, new information, new ways to look at information, new ways to determine things from the way science is changing. You know, just creates this this information that you know, you feel like it was lost. And this is 68 million years ago, and now we know, you know, we can picture an animal being attacked by this Tyrannosaur and surviving, and then later, obviously, you know, it's fed upon by this after its death, and you know, these are all pretty interesting scenarios.
I'm interested too by the cooperation this story shows, the way scholars work together on things like this because you're working with the Benesky Museum of Natural History up at Amherst College, and also with a museum, the Perot Museum of Nature and Science, all the way down in Dallas, Texas. And all these people are talking together and kind of saying to each other, you know what you might have there? You know what I think I've got here? It's really an interesting process.
Oh, it really is. And, you know, I've had some opportunity to work with people, my colleagues in the field, but this was just an incredible example of collegial effort. You know, the bone that we have, that was the upper arm bone that I'm speaking about, was actually missing some elements on either end of it, so where it articulates with the shoulder and then to the two bones in the lower part of the leg. And the Perot Museum they have one of the largest articulated Alamosaurus. That's sort of their unique specimen that they have in the hallway of their dinosaur hall, and it's just a beautiful, beautiful cast, mostly cast material, and from the measurements that they gave us and some illustrations, we were able to complete the two ends of the bone. So what we had originally was 51 inches of material, and we actually added 18 more inches of material on each end. And so it turns out, again, it's the largest humerus that's been found from that area. And, you know, being able to talk to your colleagues, you know, they share the excitement of this new, you know, obviously they have the Alamosaurus reconstruction there, and so a lot of their work has been compiled from different research around the country, and so they've been putting that together, and, you know, for them it's thrilling that some other information has come, you know, to light that they had no idea was around. So, you know, it works both ways.
It's a fascinating story, 68 million years in the making. David Stier, director of the Springfield Science Museum at the Quadrangle. Thanks for coming in, sir.
Well, thank you very much.